In this video, you will learn how to factor by grouping. So to factor by grouping, we first need to understand how to factor. So here we have BA plus CA, and we can factor that because they both have an A in common. I can pull an A out of parentheses, and in parentheses I'm left with what's left over, which is going to be the B and the plus C. Alright, that's how we factor. We pull out what they have in common. Now the letter A could also be a polynomial. So example 1, we have A equals x minus 3. So instead of like B times A and C times A, we have B times x minus 3 and C times x minus 3. Well, notice they both have an x minus 3 in common. X minus 3 here and here. So what that means is that I can pull that out. So I pull that out, I have x minus 3 on the outside, and in parentheses I have what is left over, which is B plus C. So that can factor to become x minus 3 times B plus C. So it's just factoring, but with a polynomial instead of a single monomial. Another example, instead of B times A plus C times A, we can have maybe B times 2x minus y plus 4 plus C times 2x minus y plus 4. Notice they both have 2x minus y plus 4 in common. So I pull that out, and I'm left with, in parentheses, the B plus the C. So this would be factoring by grouping. Here are some more examples. Next we have 4 times 2x minus 3 minus y times 2x minus 3. Well, they both have a 2x minus 3 in common, so I can factor that out. So I factor out a 2x minus 3, and in parentheses I'm left with what is left over, which is a 4 and minus y. So my factored form would be 2x minus 3 times 4 minus y. Another example, a times a plus 3b minus a plus 3b. This one looks a little different because there's not something in front of this other a plus 3b, but there is an assumed 1 because there is one of these a plus 3b's. So we can assume there to be a 1 in front. So they still have an a plus 3b in common. I factor that out. And then in the other parentheses, I put what is left over, which is a minus 1. So this can factor to become a plus 3b times a minus 1. Okay, here's another example. We have y plus 3 in common, so I factor that out. I'm left with, in parentheses, what is left over, which is x minus 4. So this factors to become y plus 3 times x minus 4. We can also have exponents in here as well. So they both have a 2y plus x in common. I can factor the 2y plus x out. I'm left with, in parentheses, what's left over, which is the u squared plus 3. So my factored form would be 2y plus x times u squared plus 3. If we wanted, we could also have more than 2 terms. So here we see 3 different terms altogether. So 3a times a minus 2b plus b times a minus 2b plus a minus 2b. So notice they all have a minus 2b in common. Alright, and another thing to note is that there is an assumed 1 in front of this last term. So with that being said, we can factor out what they have in common, which was the a minus 2b. And then in the other parentheses, we put what is left over, which is 3a plus b plus 1. So my factored form would be a minus 2b times 3a plus b plus 1. Now, as we factor by grouping, we're going to get into some more difficult types of questions. And as we progress, it will be helpful if we know how to recognize opposites. So for example, if you had y minus x, then the opposite of that would be negative, and then parentheses y minus x. Because negative means opposite of. So another way of writing the opposite here, we can think of this as a negative y and a negative x, which becomes a positive x. So this would be negative y plus x, or we can write the x first to have positive x minus y. So we don't need to always go through all these intermediate steps, but notice the beginning and end result. We had positive y, negative x, and then the opposite would be a positive x and negative y. So y minus x minus y, those are opposites. So same thing with 2 minus h to the third power. The opposite would be making everything negatives, like changing the sign. So the opposite of 2 minus h to the third would look like this. And then what that means is we change the sign to become a negative 2 and a positive h to the third. And you can write the h to the third first and the negative 2 second to get h cubed minus 2. One more example, we have 2a minus 3b minus 4. So the opposite of that would be taking negative and then parentheses all of that. So what that means is we make the positive 2a into a negative 2a, the negative 3b becomes a positive 3b, and the negative 4 becomes a positive 4. And we can rearrange this if we want. We could put the 3b first, and then the minus 2a, and then the plus 4. So this is all the same thing, and these are all opposites of 2a minus 3b minus 4. Now this will come into play as we get into some more difficult questions with factoring by grouping. So let's take a look at one of those examples. Here we have 2b times 3a minus 2 plus 2 minus 3a. So the objective is to group things together, so factor by grouping. But we notice here we have a 3a minus 2, here we have 2 minus 3a. Notice that the only thing different is the sign. Here's a positive 3a and a negative 2. Here's a negative 3a and a positive 2. So these are opposites. So what I can do is I can make them the same. I can force them to be the same so that I can factor by grouping. So as we stated in the previous slide, 2 minus 3a would be the same thing as the opposite, right? Opposite of 3a minus 2. So the minus makes it opposite. So if that is true, what we have now is 2b times 3a minus 2, and plus and minus would be just minus. So minus and then 3a minus 2. So we have forced this expression to be the same, where now we have 3a minus 2 and 3a minus 2. So now we can factor by grouping. They both have a 3a minus 2 in common. I can factor that out. And then what's left over is 2b, and then you have minus, and this is an assumed 1. So 2b minus 1. So 3a minus 2 times 2b minus 1 is the factored form of the original expression. And that is what you see right down here at the bottom. Example 9. A similar type question where we have 4 times parentheses x minus 2 minus 3y times 2 minus x. Notice that in the parentheses, the only thing different is the sign. And here we have a positive x and a negative 2. Here's a negative x and a positive 2. So I can recognize this as being opposites. So we know that 2 minus x is the opposite. So the opposite, negative opposite, of x minus 2. So we have this, and now we can pull this negative out. We have negative 3y and then times negative. So this would become a positive 3y. All right, because this is one thing here, and then here negative 3y times negative 1 is positive 3y, and times that by x minus 2. All right, so we can rewrite the original expression as this. And notice what really changed from the beginning right here. We just changed this negative 3y into a positive 3y, and then changed this to be the opposite, x minus 2. So you don't always need to do the intermediate step, but the reason for our solution right here is because of that intermediate step. But eventually you can do that in your head. So at this point, we see that they do both have an x minus 2 in common. So I can factor that out. And then what's left over is going to be the 4 plus 3y. So my factored form is x minus 2 times 4 plus 3y. Let's do one more example like that. Here we have x times y minus 1, then minus 2 times 1 minus y. All right, so like we said, eventually we can start doing this in our heads a little more without showing all of our steps. We notice that in parentheses we have positive y, negative 1. Here we have negative y and positive 1. The only thing different is the sign. So what I can do over there to make it the same is I'm basically pulling a negative out. So the negative 2 becomes a positive 2, and I change the signs into a negative 1 and positive y. We'll put the positive 1 first. So positive y and negative 1. So that made these two terms the same. All right, so that's what we have right here. And then at this point, notice that they both have a y minus 1 in common. All right, and actually let's do it down here. They both have y minus 1 in common. So what I can do is I can factor that y minus 1 out. I'm left with, in parentheses, an x and a plus 2. So what I have is y minus 1 times x plus 2. And that is my factored form of the original expression. Now there may be times when you need to factor out a greatest common factor first before you start doing things. So for example, you have 12y squared minus 8xy minus 4 times 3yz minus 2xz. So for both of these set of parentheses, I can pull out a greatest common factor. For this first parentheses, 12y squared and negative 8xy. The greatest common factor would be 4 and y. All right, so I could pull that out. Over here, they both have a z in common, so I can pull a z out, so it's with the 4 outside. So the question is, what goes in the parentheses? So for the first one, 4y times something is 12y squared. Well, 4 times 3 is 12, and y times y would be y squared. And then for the second term, 4y times negative 2 gives me negative 8, and then we need an x here as well. So 4y times negative 2x would give you negative 8xy. For the second set of parentheses, let's look at the z. We pull the z out. So z times what would give me 3yz. That's going to be 3 and y. All right, so the z we pulled out, multiply that with 3y, would give me 3yz for that first term. All right, and then the second term, z times something, gives me negative 2xz, and that's going to be a negative 2x. All right, so in parentheses over here, we have 3y minus 2x. Now at this point, we can pull things out because they both have 3y minus 2x in common. So I factor that out, 3y minus 2x. In the other parentheses, I'm left with what is left over, which is 4y and then minus 4z. So here, we have completed factoring by grouping. And you may notice that right here, we can actually factor out a 4. They both have a 4 in common. So I could actually factor that out. So 4, and then I'm left with, in parentheses, y minus z. Because 4y minus 4z would be gotten if I distribute back through. Alright, so we can also pull a 4 out. And the 4 we could pull out in the front just to make it look a little nicer. So the 4 in the front, and then 3y minus 2x, and then times y minus z. So this here would be my final answer. Okay, let's take a look at another example like this. Here we have 4x minus 4xy plus yz minus z. So what I can do is, with each set of parentheses, pull out what they have in common. So here for the first set of parentheses, they have a greatest common factor of 4 and x. And then I can think through what would go in parentheses. So 4x times what would give me 4x? Well, that would be 1. All right, and then 4x times what would give me negative 4xy? And that would be a negative y. Right? 4x times negative y is negative 4xy. And then the second set of parentheses, we have a z in common. So pull a z out, and I'm left with, in parentheses, y minus 1. All right, because z times y is yz, and z times negative 1 is negative z. So I now have this expression. And that is what we see right here as well. All right, now notice 1 minus y and y minus 1, they are identical except the signs are different. We have positive 1, negative y. Here we have negative 1 and positive y. So I can force the second one to be the same as this first one. And I do that by pulling a negative out. So make this into a negative z. And then this becomes, instead, 1 minus y. So we have 4x times 1 minus y minus z times 1 minus y. So from here, they both have 1 minus y in common. I can factor that out. And in the other parentheses, I have what's left over, which is 4x minus z. So my factored form would be 1 minus y times 4x minus z. So now that we know how to pull things out by grouping, we will have a more difficult expression where we need to factor completely on our own. So for example, we have 2xy minus 6xz plus 3y minus 9z. What I want to do is factor this by grouping, where I need to group things together so that I have parentheses with something in common. Just like those other examples, they had something in common in parentheses. That is my goal with this as well. But I'm going to make it happen. So what I can do is I could group together, in this case, the first two and the last two. So let's try that. We group those together. So when I have this, now I can factor something out of both set of parentheses. So the first set of parentheses, I can factor out a 2 and an x. That is the greatest common factor. In parentheses, I have y, then minus 3 times z. Over here, I can pull out a greatest common factor of 3, and in parentheses, I'm left with y minus 3z. So notice what I've done. I now have two things in parentheses that are the same, which means I can pull those out. I can factor out this and this. So when I pull that out, I have y minus 3z on the outside. In parentheses, I have a 2x and a plus 3. So my answer, when I factor, would be y minus 3z times 2x plus 3. So this is why it's called factoring by grouping. We group together things so that we can factor out the greatest common factor, and so that we can pull out again the greatest common factor, which would be now a binomial. All right, so now we have everything completely factored. And there's different ways you can do this. You don't always have to group together these two, like the first two and the last two. You can always group things together differently, and you'll get the same result at the end. So here's all the steps typed up for you for that first example. But there, like I said, are other ways you can solve this, and I want to show you a different way you could regroup this, and I want to point out something that you need to be careful of if you decide to group things in this other way. So given that initial problem right here, what I could do is I could rearrange, and I could have the 3y over here, and then negative 6xz minus 9z. All right, so I could rearrange this. And now if I were to group this together and then this together, you need to be careful when there's a negative in the front of the second parentheses, because parentheses means that whatever's in front goes to everything in parentheses. So with parentheses, now this is saying you have a negative 6xz and a negative 9z, which would make that into a positive. Well, it wasn't a positive, it was a negative. So if you group it together like this, and there's a negative in the front of the second parentheses, you must change this sign to account for that negative. So what that would look like would be this. We change the sign into a plus 9z, because if I were to distribute this negative to both terms, we would have a negative 6xz, which is what we started with, and a negative 9z, which is what we started with. If you didn't do that, it'd be a plus 9z, which is wrong. And then from here we can factor out and get the same answer. So just be careful if there is a negative in the front.